warm greeting to everyone. This is Mrs.M.Jasmine, Assistant Professor, Department of Information Technology. Here we go into the topic microprocessor and how it is implemented in this real world.
Microprocessor. A microprocessor is the central processing unit of a computer which is built into a single integrated circuit. Next we'll pass on to single processor. A single processor is a system which consists of only one processor in it. It may be a desktop or a smaller computer such as laptop, notebook, etc. For example, it may be a small or laptop or a notebook. The next is multiprocessor. A multiprocessor is a system which consists of more than one processor in it. A CPU has many processors along it. A CPU of a powerful server or a mainframe computer or a supercomputer is a good example. Next we'll pass on to the evolution of microprocessors. The first microprocessor was Intel 4004, which was introduced in the year 1971. The Intel introduced 4004, which was a 4-bit processor, and it was capable of performing 4-bit operations. Next is evolution of microprocessors. The few more companies manufactured microprocessors along with Intel microprocessor. The few companies like Motorola, Sun Ultraspark, Texas, MITS, IBM, AMD and Apple also manufactured 4-bit, 18-bit, 8-bit, 16-bit and 32-bit processors. Next is the microcontroller. The microcontroller is a digital computer which is built into a single chip. These microcontrollers are used for control and instrumentation purposes. The microcontrollers contain CPU, ROM, RAM and I/O ports. A powerful microcontroller consists of AD converter and DMA channels. The powerful microcontroller is a good example of microcontroller. In 1976, Intel introduced 8048 series of 8-bit controllers. The members of 8048 series were 8048, 8748, 8041, 8741, 8021, 8035, and in 1980s Intel introduced 8051 series, which is a more powerful 8-bit controllers which is very faster. It has enhanced instruction set. Next is the embedded processors. The embedded microprocessor is the next category, which is again categorized into event control and data control. The event control processors are, which is nothing but a microcontroller. It is used for real-time purposes as a real-time controller. Event control is otherwise known as real-time control. For example, a controller of electric motor or engine or indicator, and a temperature control of an oven or furnace. The next is the data control. The data control is used as a embedded microprocessors for controlling the data. The applications require data processing, data formatting, I/O control and DMA transfer. Example, digital camera, digital wristwatches, refrigerators, washing machines, microwave ovens, calculators. Next is the bit slice processors. These are all the customized processors which is uniquely designed for each application. The building applications include 4-bit ALU, microprogram sequencer, a carry look ahead generator. Next is the microprogramming technique. There are two approaches to design control unit of CPU, namely hardware approach and software approach. In microprogramming technique, the microprograms are loaded into control memory initially from the auxiliary memory. The next address generator will send the address to the control address register, and in turn it sends the address to the central control memory and to the control data register. Next is the hardware approach. Hardware approach is the RISC design. RISC is Reduced Instruction Set Computer. RISC does not use microprogramming technique. RISC is very faster, but the design of control unit is difficult and complicated. Next is the software approach. The software approach is CISC design, Complex Instruction Set Computer. It is based on software, and the CISC uses microprogramming technique, and it is very slower but very simple. Next is the scalar and superscalar processors. The scalar processors are only one data at a time. It processes a single data at a time. The scalar is a single instruction, single data stream CPU. It executes integer and floating point operations. The superscalar contains multiple pipelines and executes more than one instruction per clock cycle. Next is the vector processors. The vector processor performs vector computations. It uses n number of pipelines, and it can perform array of operands of same type. Operands can be integer or floating point or logical values or character. It is used to perform same operation over set of operands. Next is the array processor. The array processors are also capable of performing vector computations. The array processors are of single instruction and multiple data type. It uses n number of processing elements. The processing elements are which consist of arithmetic and logic unit with a local memory. It uses number of processing elements which access with the control processor. Next is the symbolic processors. Symbolic processors are also called as prologue processors or Lisp processors. These processors are required in expert systems, machine intelligence, knowledge-based systems, and pattern recognition. These processors are used to perform basic operations required for artificial intelligence like logic inference, compare search, pattern matching, filtering, reasoning, and retrieval.
I hope everyone enjoyed this video. Thank you for watching this video.